Hello everyone. Just imagine this. What if we could predict a flight accidents even before the planes take off? Sound impossible, right? But with the power of machine learning, it's totally possible. In this video, I'm going to show you how I can build a flight accident prediction model using machine learning. And trust me, this is not just a project, okay? It's something about that can save actually the human lives. Now you might ask, why we need a prediction on flight accident? Flights are already super safe. Yeah, they are. But accidents still happen due to the bad weather, pilot stress, faulty routes, and sometimes data being ignored. Just remember the Ahmedabad flight accident. We just lost our 250 good souls. What if we had a system that might say, hey, this flight might be risky, don't take off? That could change everything. Okay, let's talk about the power of the project, the data set. I have trained the machine learning model using flight data like flight type, airline type, weather during takeoff, pilot experience, route complexity, and altitude, wind speed, and lot more. Each small detail helps the machine learning model to understand whether the flight is high risk or not. And the coolest part was I made the real-time application. I made this project as a real-time application. So anyone like airline stop, airport control, why not? Even you can just enter the flight details and click the predict button. That's it. It shows the probability of the accident. If the system thinks the flight is risky, it immediately shows high risk, don't take the flight. It shows as the flashing alert. So yes, we have to prevent better than regret. I used Python to build the machine learning model. The particular model I'm using was Convolutional Neural Network. I also used the Flask as a backend, and I made the front end using HTML and CSS to keep this project as clean as well as the fast. So yes, it's simple stack, but the most powerful one. So if you are a student, you are watching this, just listen up. This kind of project is not about the college marks as well as your resume worthiness and all. It's about how we are using your skill to build the real-time project that could actually save the human life. And honestly, learning machine learning is not about just building the real stuff. It's more fun than just reading the dry theory as well as the definition. In this video, I'm going to explain the base paper from where the project core idea came from, as well as the project PPT with the flowchart, system design, as well as accuracy report and all. And finally, the full demo of the working project. Even if you are a beginner, just stick with me till the end of the video. You will get everything you need to understand, build, maybe even you can improve this project in a real time. First of all, I can explain the project base paper for you. So this is the project folder. Here in the project folder, you can find the base paper as well as the project presentation here. I can explain the project base paper first. So this is the project base paper we are taken for this project. So it's published on IEEE 2025. It's a paid IEEE paper. Okay, it's a very recent paper. The base paper titled as Prediction of Injuries and Fatalities in Aircraft Accident through Ensemble Hybrid CSR net approach. So this is the project base paper. Basically, what they implemented in the base paper means they are applied ensemble model. Okay, they are applied ensemble model. With the help of ensemble model, they have formed the deep learning approach. Why they are applied a deep learning approach means they are going to predict the injuries as well as the fatalities in aircraft accidents. So basically, this base paper will be applied after the accident only. They're not going to predict the accidents. Instead of that, what they did means after the accidents, they're going to calculate the prediction of injuries as well as fatalities using the machine learning model. That's what they have implemented with this project. Okay, so this is the architecture they have implemented with this project. Okay, so you can see their architecture. They are feeding the input data here. After feeding the input data, they applied some random cleaning or pre-processing operation. Once the pre-processing completed, they are moving for the feature engineering. In the feature engineering part, they are going to calculate the important features from the data set. Then it will move for the deep learning part. In the deep learning, they are going to feed the related flight accident images or else any videos. Based on that video or image they are given, it will calculate the number of fatalities or injuries happen to be their accident. Okay, so this project will not be applied for, this base paper will not be suitable for before the prediction of accident. So it used to calculate the injuries after the accident. It's completely basic when compared to our base paper, our project. So this is our project. Okay, this is our project. It's very advanced when compared to our base paper. This one is very advanced. I can explain the project PPT now. Okay. So the project titled as AeroSafe. The project titled as AeroSafe. Real-time flight accident and risk prediction system using machine learning. Basically, this is our proposed system. It used to predict the accident before the takeoff itself. So once we are flying or the accident happened means it will not be useful. So before the takeoff itself, this project will predict the accident. With the help of that risk prediction, we can overcome these casualties or injuries or death or even the accident. So this is the major motto of this project. So we are given name as the AeroSafe, which is very short form as well as short and simple for this project. I can explain the abstract for you. So basically in our proposed system, we are going to use CNN, Convolutional Neural Network. Okay. So we have to give the comparison between the base paper as well as the proposed system. I can give you the comparison between the base paper as well as the proposed system first. So this is the comparison between the base paper as well as the proposed system. In the architecture side, you can see the base paper utilizes the ResNet model, the deep learning approach as the proposed system, but we are going to use convolutional neural network to predict the accident. This is our proposed system. The existing base paper used to predict the casualties as well as the death ratio after the accident. But our proposed system going for the dynamic approach, which is going to predict the accident even before the takeoff. So there is a difference. As well as the existing system does not useful for the real-time application, it's designed for the research purpose only. But our proposed system is a real-time one. It uses the weather APIs, real dynamic data. It will predict the approach, predict the things in a real time. As well as the existing system completely focused on the injuries and casualties, but proposed system completely focused on the accident and risk ratio. The existing system is not a real-time one, so that you can't expect any user interface or any things and all. It's completely research model. You are going with the algorithm only. But our proposed system uses the backend as well as the front end. In the front end, the user can directly log in, register, or even they can give any data. They can check for issues and accident ratio and what is the casualties they are going to expect. Everything it can be predicted. And one more thing, you can download the PDF report. What's the percentage of accident risk ratio? What is the percentage of safer ratio? What's the issue on the accident? Okay, you can get the PDF report. Key output. The existing system majorly I already told you now, it's focused on injury, but our proposed system focus on accident prediction. So this is the comparison. I can explain the complete PPT. So this is our project abstract. The project abstract, I mentioned, we are going to use convolutional neural network as our proposed system. So the key feature is we are using live weather APIs and all. It's a dynamic project. It's a up-to-date project. Okay, even the data set which you are using is around 10,000 plus data we are going to consider. Okay, it's a very live project. So in the introduction section, we have mentioned that what's the main motto of this project. The aviation industry facing large amount of safety related issues, so that we have to provide the technical insight for the aviation industry to overcome those casualties as well as accidents. So we have to use the powerful machine learning model, which is called as convolutional neural network. That project dataset uses 2,500 plus flight data. Flight data itself 2,500 data. Overall, the data comes around 10,000 plus. Okay. So here we are going to use two prediction. What's the meaning of two prediction means? One is for basic user, another one for advanced user. What's the meaning of basic user data means? In advanced user, you have to give the flight model. What is the airport code? What is the destination code? What is the route safety? What is the weather? You have to give what is the pilot experience? What is the co-pilot experience? What's the crew size? How much maintenance the particular aircraft faced in the last year? You have to give this technical data set. Okay, this is for advanced user. We are designed for advanced user as well as basic user. So even if you are the advanced user like a aviation officer or even you are a flight or a flight engineer, you have to give all this data to predict about the flight accident. If you are basic user, you are the passenger, you don't know about any technical things, you just need the source as well as destination, the starting point and end point. That's what you know means go for the real-time prediction. In the real-time prediction, you are direct passenger. You can give the starting point and end point. It will fill all the data itself. It will give the prediction whether the flight going to take the accident or not. So that is the main difference between the manual as well as the real-time. This project offers both. So it's go for the technical person also or for the basic person also. It will work for both the person. That is the main advantage of this one. So project vision and all. So this project is a very predictive model. So if you're going for the prediction means the main target itself, the accuracy should be the higher one. This project produces 98.7% accuracy, which is very higher. You do get nearly 99% accuracy with the help of CNN, convolutional neural network, which is very much higher. Also, this project is a real-time one. So you can fix the worthable of this project, okay? So this is the literacy survey. Basically, for the PPT purpose, I have taken 5 recent papers. I have compared with our proposed system model. You do get the report with this project. In the report section, you do get many comparison compared to the PPT things. So this is the existing system. Usually, the manual, the basic existing system go for the manual weather-based approach only. So if the weather is good, they are making this project, the flight is a safety. Weather is bad, flight will not be landed successfully. Like that, they are doing manual prediction. It won't be accurate when compared to our proposed system. But our proposed system uses nearly 20 plus features. Okay, you have to give the flight age, what is the aircraft age, what is the aircraft model, what is the maintenance time it's faced, what is the flight time, what is the air time, what is the how much the main pilot having experience, what is the experience of co-pilot, what is the crew size, what's the flight model, what's the flight company, what is the aviation industry it comes under, what's the weather data, what's the route safety, wind speed. It captured all this data. Based on that only, this project will give the security alert, the how much risk percentage the aircraft taken, like that. Okay, so the main drawback of the existing system was it's not a real-time one. When compared to the real-time one, it's getting failed. Static result. The existing system produces static result only, not a real-time result. So existing system majorly uses the human intervention so that it will lead to the human errors. But proposed system is a dynamic one. Okay. So this is the comparison between the existing as well as proposed system, which is I already explained on the initial stage of PPT explanation itself. So when it comes under the main drawback of the existing system, you can find this is the existing systems. Okay. Come to the proposed system. In the proposed system, the AeroSafe model is a modern as well as intelligent alternative for the traditional system, which uses a convolutional neural network as a back-end application. Okay, it will recognize all the complex input data as well as it will form the non-linear relationship between the flight data, pilot data, as well as the weather data and route data. It will form all the non-linear relationship between all the data set. That's why we are going for the convolutional neural network. As I mentioned earlier, it uses manual mode as well as real-time mode. What's the manual mode means? It will for the technical prediction. What's the real-time mode means? It will go for the passenger prediction. So in the manual mode, you have to give multiple flight parameters. So it's for the aviation officer or flight officer, flight engineer. They have to give various parameters as an input. What's the flight age and you have to give nearly 25 plus features. Based on that, it will give the depth analysis about the accident as well as the risk ratio. So even if you are the real-time passenger, you don't know about the technical thing, directly go for the real-time mode. You can go with the starting point and also end point. We are starting from Chennai. I'm going to land up in Delhi. I'm traveling on this particular day. That's it. It will give the accident risk ratio. So we are given manual mode as well as accident. Both the modes we are given with this project. Okay. So this is our proposed system, So the proposed system is a completely very easier user interface. Why? Because we are going to use HTML with this. So user direct visualization, pop-ups and downloadable reports, whatever features you are expecting, the proposed system having all those features, which is already implemented with the help of CNN, which is a very dynamic project from our side. So the proposed system is a very worthable one. Here we are using pre-trained libraries called as Xpert as well as PKL files. You do get the training codes also with this project as well as pre-trained libraries also. So even if you want to train your own data, you can train with that. So you no need to train directly go for the testing. You can go for the testing with the help of pre-processing files. Okay. So we are going to use Flask as the backend for this project. Okay. So this is the technical architecture for this project. So we have to use flight details and we have to use real-time weather data. With the help of all this data, we have to do the pre-processing. Then the convolutional neural network from the pre-trained libraries, it will give the visualized result as well as the PDF result, okay, for the future safety purpose. So we are given use case diagram, activity diagram, sequence diagram, class diagram, ER diagram, everything with this project, okay. It's just very downloadable. If you are purchasing this project, you do get the report with that. Inside the report, you do get all these things, okay. So models, this project uses 8 models, okay. This is very big project, so that we are going to use 8 different models. So those called as user authentication model, pre-processing model for pre-processing the data set, then training model which uses the convolutional neural network to train all those data. Then prediction model, it comes under 2 predictions, so real-time prediction as well as the manual prediction. Inside the manual prediction, you go for the technical prediction about the flight officers and all. In the real-time prediction, you can go for the user side. So then visualization, inside the visualization model, it will plot the various graphs related to the accident, related to the security for easier understanding. Then admin dashboard model, inside that you can update your data set, or you can retrain the data set as well as. Last, the visualization model means it will give the accuracy, loss ratio, then what you are expecting, confusion matrix, everything comes under the chart visualization model. Those are the 8 different models with our project. To implement this project, we need a Windows or Mac system. Basically, we need 4 GB of RAM to run this project. So this project uses Python, HTML, CSS, JavaScript. These 4 languages used under this project. For website framework, we are using Flask with this project. So this is the advantage. The main advantage of this project called as real-time risk prediction. So again, I'm saying this is a real-time project, data-driven and objective assessment. So this project uses comprehensive flight data, which is very higher on real-time. So this is the real-time one, objective data-driven approach. So dual prediction. Again and again, I'm mentioning this project uses 2 prediction for advanced prediction as well as the user side real-time prediction. Dual prediction available for this project. Then scalable. So you can enlarge this project to whatever your wish. It's a real-time one, you know. So automation of report generation. Once the prediction done means it automatically will give the report, a downloadable report for your future assessment. Then enhanced situational awareness. We are going to use 25 plus features so that the prediction was a real-time situational awareness prediction. Okay, it's not a basic prediction, it's a real-time prediction. So conclusion, this AeroSafe system represents the giving the breakthrough to the aviation industry regarding the safety. Why? Because we are using artificial intelligence on the real-time data analytics. By applying the convolutional neural networks, you can train large amount of data related to the flight parameter, then weather parameter, crew and pilot parameter or route parameter. You can combine all together to make the prediction. So it uses dual mode prediction for the easier and flexible support. It's a web-based approach so that person without knowledge also easily can be accessible with this project. Okay, that's the conclusion. We are given reference also for this project. So resources, then thank you. Okay, next I'm going for the demo of the project, how to run this project, how to get the output and all. Connect with this video. Thank you. I'm going for the project demo. That means how the project works and all. So this is our project folder. You can find the code folder. Inside the code folder, you can find the complete project data set. Then our project main code app.py, then train code. So you can get the HTML templates, everything you can get with this project. Okay, so complete project is available here. So first of all, I can explain the project data set. So this is our project data set. So it's our custom data set. You can't get this data set on online. Okay, so you can't get this data set online. This is our custom data set. We have formed this data set with the various research as well as the data collection. That is the major importance of this project. You can check the result here. So this is the flight ID, airline Indigo, Star Air, Alliance Air, Indigo, Flybig, Star Air, SpiceJet. So this is the airlines company. What's the aircraft type? Boeing 731, Airbus, Dorinardo, ATR 72, Airbus. So this is the particular flight model. Aircraft age 25 years, 18 years, 13 years. So this is the phase. Then flight phase. So it's a cargo flight or taxi flight or a it's on a landing stage or it's on parking stage. So what is the flight pace? It's en route. So what is the pace of that? So departure airport code. So this is a particular code for the airport, Chennai, Kolkata, like that. They are using the particular code for that. Then arrival airport code. So flight duration, what's the journey time? So what's the journey time? So 2.93 hours, 2.92 hours, 4.3 hours. So what's the last maintenance hours? Last maintenance hour. So 939, 250 hours. So engine hours since the last overhaul. Engine hours since the last overhaul. Then pilot experience, co-pilot experience, number of crew, total onboard passenger count, what is the cargo weight of the overall luggage, what is the particular journey time and date. So this is the data set we have taken. What is the international time, what's the season, summer, monsoon or wind, what's the visibility, what's the wind speed, what's the wind direction, then what's the temperature on that particular day, wind perception, weather condition, turbulence, then departure airport. This is the important feature here. Departure airport elevation and arrival airport elevation, route condition, air traffic condition. Based on that, the data set will tell, so it's having accident ratio or not. So 0 means no accident. You can find 1 on some places. So this is the accident one. So this is the accident based one. This complete already accident happened on this particular data. Okay, due to this destroyed weather, you can find it here. Okay, so here you can find the accident data. So here you can find the accident data. There is lot of data related to accidents also. So this is the data set which you are going to taken for this project. Okay, the complete data set is available. So you can find the training code. The training code is mentioned here. This is the training code. So you can find it here, training code. Inside the training code, you can get the complete training accuracy, pre-processing and everything. I can show the accuracy for this project. This is our CNN model formed for this project. So I can show the accuracy. So this project uses 98% accuracy. You can get nearly 99% accuracy. So you to get the accuracy 1. So I can show the graph for accuracy and all. So you can get the graph. For training, you to get accuracy around 1. That means 100. For validation, you to get 98% accuracy. So this is the loss for training as well as the validation. You do get the minimal loss only. Confusion matrix. So you can get the overall accuracy 98%. Then accuracy, precision recall values, everything you can get this for this project. Okay, so this is the thing about the training. So without wasting much further time, I can run the project for you. To run the project, go for the project terminal. So open the project terminal. I can go for the running. So this is the project execution. Copy the location. Use cd space, paste the project location, then enter. Type python space app.py. That's it. Python space app.py. It will execute the code. Once the code executed means it will form the localhost. With the help of the localhost, you can get the project. So this is the localhost. See that? This is the localhost. Just click the link. It will open the website. So this is our home page of the project. So this is our home page. So it's very real-time one, very decent also. The UI also very decent one. Flight accident prediction system. Predicting flight safety for a safer tomorrow. So it's a machine learning for aviation safety. So you can get the things. It's mentioned about the project features. What's the steps involved with this project? So preventive measures as well as incident analysis. This is the home page of our project. So there are multiple options available. About page. Inside the about page, it will mention about how the project was working. So why the project have been implemented. So everything it's explained. So what is the solution we are going to offer for this project is available on the about us section. Okay, what's the important and future vision of the project? Everything given on the about us section. Then go for the prediction. To get the prediction, you have to log in first. First, what I'm going to do, I'm going to log in with my user ID. So my user ID was user1. My password was pass123. This is the password I'm going to use. User1 and pass123. Just click login. Once your login successfully means there are two options available. Whether you can go for the advanced prediction or real-time prediction. Both options available. If you go for the real-time prediction, just select the airport, then arrival place, then particular date, which date you are going to do. That's it, travel. You can predict the results. If you go for this is for the common user. If you go for the advanced prediction, inside the advanced prediction, you have to give various parameters to get the prediction. So first of all, you have to enter the flight details. Inside the flight details, you have to enter the flight duration, what's the flight phase, departure airport code, arrival airport code, departure airport elevation, arrival airport elevation, what's the weight of the flight, how much the passenger have been onboarded, so what's the maintenance data about the aircraft, what's the pilot data, what's the weather data, what's the route data. You have to enter all this data to get the results. If you are the airport authority, if you are the flight engineer, you have to fill up all this data to get the results. No, you don't know anything, directly go for the real-time prediction. Just give the starting point, just give the end point. So based on that weather, it will use the weather for the prediction. Already I mentioned the real-time processes uses the weather for the prediction. Okay, so it's a advanced prediction. You chooses multiple part for the prediction. First of all, what I'm going to give, I'm going for the advanced prediction of this project. To give the advanced prediction, you can get the data from the dataset itself. You can get the data from the dataset itself. You can give this. Okay, all this data is available on the dataset itself. For example, so if you want to go for the flight duration, it's given here, flight duration. So you can get the flight duration available here. Okay, duration. So it's given here, flight duration. Same for the next one, flight phase. Flight phase. So all this data available here. Okay, if you go for the flight phase, it's available here, flight phase. Then if you go for the departure airport code, if you go for the departure airport code, you can get the data here. Arrival airport code, departure airport code. So if you go for the elevation, departure airport elevation and arrival airport elevation, you can get the details here. Elevation. So departure airport elevation, arrival airport elevation, all the data given here. First of all, I will give some random data here about the accident prediction and all. So my flight duration, okay, so I'm going to travel for 3 hours, so that means 3.0. So I was about to take off, so I was about to take off. Departure airport code, so you can get the code here. Okay, this is Hyderabad, Kochi, like that. So departure airport elevation, so I'm a flight officer, I have to give the detailed thing here, so I'm going to give 780. Arrival airport code, so I'm going to give LK Lucknow. Then arrival airport elevation, I'm going to give 130. So what's the total passengers on board? I'm going to give 250. What's the cargo weight? I'm going to give 4,000. 1,400. So 1,400 was the cargo weight. So then I'm going to use airline. The particular model I'm going to travel was SpiceJet. Then what's the particular model? Boeing 737. What's the aircraft age? It's nearly 18 years. Last maintenance, above 700 hours. Engine overhaul, it's around 1,800 hours. What is the experience of the pilot? So first pilot, major pilot having 6,000 plus hours, co-pilot having 450 hours. Number of crew, I'm having 4 crew, so that means the air hostess and all. What's the weather condition? So I'm going to travel in a post monsoon season. So currently the weather was clear. Visibility, I'm going to get around 10.0 as a visibility. What's the wind speed? I'm getting 7 knots wind speed. Wind direction, I'm getting 250 degree as a wind direction. Today temperature 36.0. Wind perception. So I'm going to get 0.0 only. Turbulence severity was light. So route complexity was very low complexity. Traffic density was medium. So traffic density. Now I entered all these parameter. Based on that parameter, this algorithm will work whether there is any risk or not. It will predict and give the result. Just click predict analysis. That's it. Low risk of accident. Your flight appeared to be safe. Continue monitoring. The probability of accident was 0. So that's how this project works. Just click download report. So once report downloaded, just click this. You can get the report. So what's your input parameter? This is your input parameter. Based on that input parameter, you are getting accident ratio was 0.0. So that means the flight won't get any accident. So favorable weather conditions, standard route complexity, everything was in our favorable state only. So there is no chance of accident. Also, you can get the report generated on 18/7/2024. So how perfectly this work? Okay, then I can give another data. So go for the same advanced prediction. I'm going to use same advanced prediction. Now what I'm going to do means I'm going to give the data related to the accidents. I'm going to check whether it's going to predict or not. So okay, I'm going to form the data relevant to the accident. It will predict or not. Then we can check about the project accuracy. Just go for the advanced prediction. Now I'm going to enter the data related to the accident, which is taken from the data set. Okay, so I'm going to enter the data. So the duration I'm going to give 2.2. The flight phase I'm going to give takeoff. Then I'm going to give departure airport code BOM. Then departure airport elevation 39. Then arrival airport code I'm going to give ATQ. So I'm going to give ATQ as the arrival airport code. Then I'm going for the arrival airport elevation 39. I'm going to leave it as a 39. Then arrival airport elevation I'm going to give 765 for the arrival airport elevation. Then I'm going for the total on board. I'm going to give overall 302 passengers, cargo weight 9,458. This is the data I'm going to give for the cargo weight. Then I'm going for the aircraft and as well as maintenance data. The aircraft I'm going to take in as a airlines aircraft. So this is the airlines aircraft. The particular flight model I'm going to take ATR 72. It's very new aircraft, so 2 years old. But the last maintenance was before 711 hours. Engine overhaul, it's taken around 4,151, which is very long to reconstruct the engine. Last maintenance about the engine. Then pilot as well as the remaining details. So the pilot having 7,360 hours of flying time. Co-pilot was inexperienced 6,072. Number of crew, including the aircraft air hostess, the crew was 4 members. Then weather as well as the environment. So I'm going to give as a summer period. The weather condition was a very cloudy. Visibility, I'm going to give visibility is a 5.87, which is very low about the visibility. Then I'm going to give wind speed as a 16 knot. So which is higher. Wind direction I'm going to give 352. That also in a irregular stage. Then temperature I'm going to give 21.4. This is my temperature. Perception I'm going to leave as a 0.0 only. So turbulence severity I'm going to give severe, which is very important feature. You can think this is a very important feature. Turbulence severity. Then I'm going to give route complexity low. Air traffic density was I'm going to give as a medium. For this data, it's working or not, we can check. So this is the data I'm going to give. So I can give the prediction, predict accident. So it's giving visibility should be 5.8 or 5.9. I'm going to give 5.9, round off value. I'm going to give as a round off value. Just click predict whether it's working or not. Now we can check. Okay. So just click predict accident. So now the prediction happened. So high risk of accidents, it's working perfectly. Okay, the data taken from the relevant to the data set related to the accident fields, it's perfectly predicting. That is the important about the feature. You can check high risk of accident, immediate attention required, considering reviewing the flight parameter. The probability of accident score was 0.63%. That means 63% the flight will face the accident. That score is the important one. And one more thing, this is a machine learning project. It will give the factors contributing to the risk, high turbulence, then standard route complexity. So these things are irrelevant. Okay, these things are causing the severity. So you have to consider this thing. Now you can download the report also. Just click download report. The report already downloaded. Click this. You can check the results. So this is your data. Okay, this is your data. Probability of accidents 0.63%. So this is your data given. You can check the data. So the turbulence, high turbulence, severe. So this is the thing causing the accident. Okay, perfectly working. This project is a perfectly working one. Okay, just close this. Then you can check for the real-time prediction. Go for the real-time prediction. You are the passenger. You don't know about any technical insight about the aircraft. You don't know anything about the technical. You only know the starting point and end point. Just enter the data. That's it. Now for example, what I'm going to do means I'm going to travel on a 25th of July. So what I'm going to do, I'm going to travel on a 25th of July. So just select the date 25th July 2025. I'm going to start from the, you don't need to enter any flight airport code at all. It's very user friendly project. So you have to enter the Kochi, that's enough. So from the Kochi to Ahmedabad, I'm going to travel. From Kochi to Ahmedabad, I'm going to travel on 25th of July. What it will do means, it will take automatically the airport code, arrival place code. It will connect with the real-time weather API. With the help of real-time weather API, it will give the prediction. Okay, just click live data. So now your travel was low risk. There is no chance of accident. You can get the report also. Just click the report. It's a real-time one. For real-time, it will give the arrival place is Ahmedabad, departure place is Kochi, flight date was 25/7/2025. That day, what's the wind perception? That day, what is the season? On 25th July, what's going to be the temperature? What's the visibility on 25th July? Now 18 only, but it's doing the future prediction. See the accuracy. Okay, now 18th, but it's going to predict for the 25th of July. What is the weather condition? That day will be the rainy day on both Ahmedabad and Kochi. What's the wind speed? On the particular day, you will get the 3.24 wind speed. Okay, perfectly it will working. Based on that indications, your accident was low risk of accident. There is no chance of accident. You can travel happily. So check. This is a very perfect project, very perfectly working. Okay, then go for the dashboard. Inside the dashboard, you can get the details about what is the important features causing for the accident. So whether was the important feature, flight phase, whether it's on takeoff or landing or in air time. So turbulence severity. So that also important feature causing for the accidents. So pilot experience plays the major role on the accident ratio. These data is taken from the data set. Okay, based on the data set is plotting this graph. Okay, so what's the visibility, wind speed? These are the important data related to the accident. And one more thing, very interesting thing I'm going to show you, which is analysis part. See the graphs. See the graph, how much accurately it examined all these features. Okay, it's a very accurate one. Okay, see the thing, accident analysis dashboard you can get. So while landing only, major accidents happened. Landing as well as takeoff. This is the major phases causing the accident. While landing, we have faced 20 accidents in past. As well as while takeoff, we have faced 15 accidents. Same for the aircraft type. If you're going for the ATR 72, that particular model caused 12 accidents. Next, Boeing 737. Boeing 737 caused 10 accidents. Okay, the Ahmedabad accidents also causing Boeing flight only. Accident by aircraft age. So aircraft having 11 to 15 years, which causes more accidents. So nearly 18 accidents caused by the 11 to 15 years aircraft. Also pilot, cruise and data. So this is the main pilot, primary pilot. The pilot having 1000 to 5000 hours of experience causes more accidents. They are in intermediate state. 10,000 to 5,000 means they are in intermediate state. They are causing more accidents. So see the here, pilot having 20,000 plus years experience, 20,000 plus hours of experience causing very low accident. So this is the major factor about the pilot versus accident, pilot experience versus accident. And one more thing, weather. So this is very interesting graphs. I can show you how to check this one. Okay, just deselect everything here, which is very interesting graph to analyze. First of all, accident with weather condition. So I'm just clicking thunderstorm. In thunderstorm, while thunderstorm, we have faced around 12 accidents. Fog, while getting fog, we are getting 8 accidents. Rain, in a rainy stage, we have faced 15 accidents. That is the major cause. Okay, while raining, we have faced 15 accidents. Dust storm, while dust storm, we have faced 7 accidents. Cloudy, on a cloudy day, we have faced 10 accidents. Clear sky, while sky is very clear, we have faced very low possibility of accident. Only 5 accidents we have faced while sky is clear. So see the things, weather plays the important role on accidents. So accident by visibility. So the visibility is lesser than 1 kilometer. If you are driving, you do have visibility lesser than 1 kilometer, means nearly 18 accidents happened. But the visibility is higher, the accident ratio was reduced. That also important feature. Accident by season, you can check. Monsoon season only plays the major role. While monsoon season, we have faced 20 accidents. In summer, we have faced 15 accidents only. Accident by turbulence severity. So if the turbulence is severe, the accident chances is higher. If a turbulence is normal, accident chances is normal. Then runway as well as traffic data, you can check the traffic data. If the air traffic was higher, then traffic also, then accident ratio also higher. While the traffic is higher, airline traffic, not means the local traffic, airline traffic was higher, the accidents we have faced 25 accidents we have faced. So airline traffic is low, we have faced 5 accidents only. So also the departure airport elevation, that also plays the important role. The departure airport was very higher stage, the accident ratio also higher. Okay, these are the important graphs. They are taken from the data set very easily with the help of our project. Okay, this is very interesting project. Okay, to get this project, just contact ieexpert.com. The link given on the website project description. Okay, click the YouTube video description. You can get the link about the website and everything. We have shown variety of project for your final year department. All the projects are very innovative project, very recent project. You can get all the projects from clicking this link. Complete demo also given for all the project. Check the demo. If the project is suitable for you, purchase from our site. Okay, thank you.